What up, guys? Welcome back to another episode of Two Men, One Course podcast. My name is Pete. I am your host and your instructor, if you don't know it already. Tyler is my friend. He will join us in a little bit. Okay. Another episode. So we're on episode 3. Who knew we would make it this far? Okay. Thank you for your support. So again, if you like it, don't forget to click like, subscribe, rate 5-star, or make a comment at the bottom. Right? It's on YouTube. So anyway, all right. So let's start with the podcast with a joke of the day. Well, how did the barber win the race? Well, because he knew a shortcut. One day I'm going to get fired because not that funny. Okay, all right. So lab 2. This lab is kind of fun. So you get to do different type of chemical reactions. All right. So I don't know how much you learn from the lecture, but I'm going to assume that you don't have much going on in your head. So we're going to review. Okay. So you should have seen that in lecture already. All right. First off, just something simple. When you do a reaction or when there's a reaction happening, how do you know if a reaction occurs? What is the sign? Right? You might be able to guess. If you see a light coming off, that's a sign of chemical reaction. Okay, for example, a firework, that's the combustion reaction of some type of metal. A precipitation, right? Color changes is probably the most simple one. If you feel hot, if you feel cold, temperature changes. That's also a sign of chemical reaction. And the last one, if you see a gas bubbling, ta-da, that's another sign of reaction. Okay. All right. Now let's talk about types of chemical reactions. So there are 2 categories. So it depends on how you look at reaction, the classification of reactions. One classification look at how atoms rearrange, right, when the reaction occur. There are 4 types in this classification. The first one is decomposition reaction. So in this case, a single reactant, for example, A, right, break down into multiple products, multiple the species, so B and C or D or whatever. For example, maybe in a movie or TV show, like a bomb, right? So you probably have heard like TNT. That's a type of bomb, right? When it break, the TNT looks something like that. When it break, after the explosion, it breaks down to smaller compounds. So we have carbon monoxide, carbon dioxide, oxygen gas, nitrogen gas, and it breaks down, right? The hydrogen peroxide, so we use to clean our wound or cut, right? You can buy it from like grocery store. When you open the cap, you have about 6 months to juice it up, and after that it doesn't do anything because the hydrogen peroxide decomposes to water and oxygen gas over time. Right? It's slow, but it's actually happening. The process of food being rotten, those are decomposition reaction. Okay, biodegradable, all those you know those stuff. All right. Calcium carbonate break down into calcium oxide and carbon dioxide. This the process of making concrete or cement. Okay. And it's carbon cycle. So I'm not talking about that. You learned that already. Anyway, just review. Another type of reaction, in this case, kind of reverse from decomposition reaction. So start with smaller reactants and combine to a larger reactant. Okay. For example, iron. That's just iron, metal, right? Combined with oxygen gas, this is the oxidation reaction to make rust. So all the rust that you see. Some artists use the color of rust, which is kind of like off red for painting. That's pretty cool. Okay. Some you might have learned it from a biology class. So an ATP, right? That's the energy unit of our body. If whatever food that you consume, it's got converted to ATP, and you do what and that's how you do like work or do stuff in your daily life. And the process of making ATP, the synthesis from smaller compounds. Okay. Another type of another example. So this one is Taxol, which is an anti-cancer agent, an anti-cancer drug made from a smaller compound. Start right here. So this synthetic route, you learn that in your organic chemistry. So it's proposed by Florida State University. All right, start with small compound, add something, you get a bigger compound, add something, you get another compound, add some more reagent, you get a bigger, larger compound, and then until you get Taxol. All right. Okay, so that's synthesis. So smaller reagent making a new reagent. All right, making a bigger compound. Now single displacement. So when we have an A and B and add C into it, so C will swap, replace B, right, and pair up with an A. Oh no, replace A, pair up with a B in this case. All right. Some examples. So copper wire, dip into a silver nitrate solution, and then turn into, so it's switch partner, the copper pair up with nitrate and silver coming out. Right, copper replaces silver. Okay. Copper 2, so copper with the oxidation of 2 has a color of blue. The color of copper 2 solution is blue. That shows that copper wire is coming out from the wire and coming out to the solution. You see the solution is blue right there. Okay. Another one, so you probably have heard this, that the alkaline metal, which is group 1 metal, react violently with water. So sodium react with water, produces sodium hydroxide and a hydrogen gas. Okay, so this is a single displacement. The last one is a double displacement. This is switch partner. So sodium pair up with nitrate and silver pair up with chlorine. Do something like that. All right. This also called precipitation reaction. So we may get silver chloride coming out. I'll take a look. So that's the sodium chloride solution, salt, basically add salt into water. All right. And then add a drop of silver nitrate. Add silver ion, come into contact with the chloride, it precipitates out right away. Okay. All right. All right, one more example. So this is also another double displacement reaction. Can you guess what product do we get here? Well, just like dancing, you switch partner, right? Just swap. Copper pair up with chlorine, right? So cation and anion. So cation barium pair up with a sulfate ion, right? So you should get something like copper chloride and then barium sulfate. Okay, but now check the structure, check the formula real quick. So copper has an oxidation number of +2. If you don't know that, well, at least I'm sure you know sulfate. Sulfate is -2. So copper have to match that by being +2. So basically this guy is +2, right? And chloride is in group 7, so -1. And then you cross over the oxidation number, copper 2 chloride. Right, chlorine is 2 right here. And next one, barium sulfate. So barium is in group 2, so +2. Sulfate is -2. And they balance out already. So if you cross it over, it's just 1-to-1 ratio. So barium sulfate, leave it like that. All right. All right. One more time. I mentioned before, previous 2 slides. So copper 2 sulfate is blue in color. Look at that. Copper sulfate. Copper 2 is blue. As you drop of copper sulfate come into contact with barium sulfate, barium chloride, precipitate out barium sulfate right away. All right. Okay. All right. Just pause the video and then classify this type of reaction for me. All right. Double displacement, synthesis, decomposition, or single displacement. The first one, the swap partner, lead pair up with iodide, potassium pair up with nitrate. So that's double displacement. Next one, aluminum and oxygen react to each other. So just combine, synthesis. This is synthesis, make a bigger molecule. All right. Now, hydrogen peroxide break down into water and oxygen gas, so that's decomposition. And iron and tin 2 chloride, so this iron replace tin. All right, so we get iron 2 chloride. So this one is single displacement. Okay, you should be able to predict the product as well. All right, so we have a solid lead 2 sulfide. So if you see 2 right here, it means that the oxidation number of lead is 2, +2. Right? This is sulfide, not sulfate. So sulfate is SO4 2-, sulfide is SO3 2-. So when you see 8 go down to 8, the number of oxygen go down by 1. All right. So sulfide, so lead sulfide plus lead +2, sulfide, same oxidant, same charge with sulfate, -2. So they balance out already. Just leave it as it is. And what's it? All right, keep going. It forms 2 new compounds: solid lead 2 oxide and sulfur dioxide gas. All right. Write a balance equation for this reaction, including phase symbols. Which type of reaction and what type of reaction is this? All right, let's predict the product real quick. So lead 2 oxide, lead plus 2 and oxygen. All right, so lead plus 2 and oxygen is in group 6, so -2. Leave it as it is. And we have a gas sulfur dioxide, so SO2. Okay, and one lead here, 3 oxygen on the right, 1 sulfur. Balance already. So this type of reaction is decomposition reaction. Okay, just to review, this is all reviewing. All right, now another classification of reaction. Now this time, this classification look into the special characteristic of reaction. For example, if you mix something together and the precipitate occur, we call precipitation reaction. This one don't really care about like what atom rearrange. They just look at what's really happening. All right, a redox reaction look at electron transfer, and the combustion reaction, fire. So that's what we're looking at, right? All right, start with the precipitation reaction. So I'm sure you have seen the solubility rules before. If you have not, it's in your textbook, right? In the lecture, you have to be able to use the solubility rules to predict the precipitate from a reaction. Okay, we're not going to go into like the detail because that's going to be a whole hour lecture. I'm not doing that, so we're going to use it. I want to just point out that group 7 ions. So we have fluoride, chloride, bromide, and iodide. Right? This group we call halide. So the halide precipitate with silver, copper 1, not copper 2. This is copper 1, mercury, and lead. Right? If the halide pair up with these 4 ions, they precipitate. Can you see that? Who's precipitate? This is a double displacement reaction. We did it together before. So what's a precipitation? So what's a precipitate? Well, sodium will go pair up with nitrate, silver pair up with chloride, right? So group 7, fluorine, chlorine, bromine, iodine pair up with silver, mercury, copper, and lead, precipitate out right away, right? Sodium nitrate, still soluble, and silver chloride, same thing right there. Check the formula real quick, check the charge. Sodium group 1 plus 1, nitrate minus 1, so leave it as it is. Right, they balance out. Silver is the only transition metal. Has a plus 1 charge. It's a transition metal, has a plus 1 charge. Chloride group 7 minus 1, so balance out. Leave it just like that. And you saw it before, precipitation. Okay. For a precipitation reaction, my expectation to you is you have to be able to write a molecular equation and a net ionic equation. I'm going to teach you right here. Just review. You should be able to see. You should have seen this already, but if you have not, take a look right here. Okay. So this is a molecular reaction. Show overall reaction, what's happening. All right. But now, what's the ionic equation? Let me explain real quick. A molecular reaction that you've seen right here. All right. Just show an overall what's going on. So we have sodium chloride react with silver nitrate. They both are soluble in water, aqueous. Yeah. To make sodium nitrate, also soluble in water, and precipitate the silver chloride. Right? This is overall reaction. Doesn't really tell you anything. This is what happened. But in reality, well, sodium chloride is soluble in water, right? Basically, if you drop a salt into water, sodium ion and chloride ion breaks down. They break apart and be surrounded by water. They form interaction, what we call an ion dipole interaction. Okay, I'm not sure you learned that yet, probably not yet. You learn it later. Anyway, so they're from an ion dipole interaction and to stabilize all these charges. All right. So basically, in solution, sodium chloride doesn't stay as sodium chloride salt. Like they disappear to become a sodium ion and chloride ion. So water surrounding it. That's why we have an aqueous right there. Chloride, same thing. Water surrounded. That's why we have an aqueous. All right. It's in solution now, so they get into the solution. Silver nitrate also soluble in water. When you dump into silver nitrate into water, they won't stay as solid sodium nitrate, so they break down into silver ion and then nitrate ion. Now go to the right side, same thing. Sodium nitrate also soluble in water, break down to sodium ion and nitrate ion. However, the last one, silver chloride, solid. This guy is not soluble in water. It's a precipitate, look like right here, right? So this guy stay as a silver chloride, solid silver chloride. Okay. So the top reaction mentioned before, that's a molecular equation. The bottom one we call an ionic equation. Show what really happening in reaction is really important because you need to know what's going on with this solid in the solution, right? An ionic equation tells you what's going on, right? So they break apart, right? This guy break apart, this guy break apart, this guy break apart, this guy stay as a solid. All right, but now you're gonna see that on the left and the right side, these two species are the same, right? So we call these two species that doesn't do anything in the reaction spectator ion. You are a spectator in a football game. You don't actually participate in a football game. You just watch, right? So that's you are a spectator. Same thing as spectator ion. They don't do anything to the reaction. Well, we can treat a chemical equation just like a math equation. Or if you see both species on the left and the right, the same thing, you can cancel them out. Cancel them out. Doesn't do anything, right? And that's who leads you a net ionic equation, right? The net ionic equation tells you what really happening, right? So what actually happening in this reaction? Well, we have chloride ion, silver ion. They from precipitate silver chloride. Okay. All right, let's try it on your own right here. So pause the video. So I want you to write the molecular equation of this reaction, an ionic equation, and then the net ionic equation. I pause the video right here. And then check with me. So we have a lead nitrate, all right, mixed with sodium iodide. All right, a yellow precipitate is formed. Write a balance equation and all of it. All right. Okay, so this is just a double displacement reaction. Lead paired up with iodine and sodium paired up with nitrate. Okay, so it should look something like that. Now check the formula. So lead is +2. If you don't know how I know that, well, nitrate on the left side, nitrate is -1. There are two of them, so the total negative on this molecule is -2. Well, the whole molecule is neutral, so lead have to be +2, so balance out that negative charge of the nitrate, of the two nitrates. Okay, so lead +2, iodine is iodide group 7 -1, and cross it over, so PbI2. All right, same thing on the right. So sodium group 1 +1, nitrate -1. So it's balanced out already. So leave it as it is. All right. Check is it balanced? One lead, iodine. Nope, iodine not balanced. So oh, I forget. So lead nitrate, so soluble in water, sodium iodide. According to the solubility rule, group 1 also soluble in water. Lead 2 iodide, this guy not soluble. Again, group 7, so fluorine, chlorine, bromine, iodine. Pair up with silver, mercury, copper, and lead precipitate. This guy right here. All right. And then sodium nitrate also soluble in water according to the solubility rule. Anyway, next one, balance equation. So to iodine, put 2 right here. That makes sodium 2 sodium. So put 2 in front of sodium on the right side. And 2 nitrate already. One lead. So we good. That is the molecular equation. Now let's go on to ionic equation. So if a species is soluble in water, break them up. All right. So lead nitrate soluble in water, break them up. So you get 1 lead, 2 plus. All right, it's a 2 plus and 2 nitrate. So we have 2 of them. So 2 nitrate ion. Now we have 2 sodium ion and 2 iodide ion. So also soluble in water. So break them up. So don't forget 2 and 2 right here. All right. On the right side, so lead 2 iodide is precipitate, so not soluble in water. Leave it as it is. And sodium nitrate soluble in water, so break them up. So we have 2 sodium ion and then 2 nitrate ion. Okay. Well, all right, that's the ionic equation. Now, before we do net ionic equation, so who is the spectator ion? Should be able to see that right there. So if you see it, cancel them out. They're just 2 on the left side, 2 on the right side. You can cancel them out right away. All right. And that leaves you the net ionic equation. Ta-da. All right. You should be able to see, to write molecular and net ionic equation in the lab. Okay. That's pretty cool. That's lead 2 iodide precipitate. All right. All right. So first type of reaction, when we look at what's really going on in the reaction, so we have precipitation reaction. Next one, we have a redox reaction. All right. So what's a redox reaction? So a redox reaction is categorized as an electron transfer reaction, which means that electron move from one atom to another. So you will see a change in the oxidation number. Go back right here. So this Precipitation reaction, the oxidation number stay the same. Lead on the left side +2, on the right side still +2. This lead to iodide. Nitrate -1, nitrate -1, sodium +1, sodium +1, iodide -1, iodide -1. Nothing. The oxidation number doesn't change, right? But in a redox reaction, yeah, they do. Let's check the oxidation number real quick. So, what's the oxidation number of aluminum? I'm not sure you know yet from the lecture, but let me tell you. So, an atom in its elemental state, so just it is, right? Aluminum is a metal, aluminum. Oxygen is oxygen gas. So an atom in its elemental state has an oxidation number of 0. Right? So aluminum, let's say aluminum foil, it exists in water, which means it's stable enough, can have charge. Charge means unstable. Okay, so oxidation number 0. Oxygen gas by itself in the air also 0. Right? You never like breathe in air and then somehow that oxygen that go into your lung just burn out your lung. Like, oh, no, that never happened. Right? Oxygen is stable enough to exist right in the air, so that's also 0 elemental form. Right? But now when they become a compound, so electron lose, electron gain, so aluminum group 3 +3, oxygen group 6 -2. Like that. Now, look at what happened to the oxidation number. For aluminum from 0 to +3, it goes up, right? When a reaction where an oxidation number goes up, increase in oxidation number, we call an oxidation reaction, just by its name. Conversely, a reaction with a decrease in oxidation number, we call a reduction reaction. Reduce, come down, decrease, right? Reduce. So reduction reaction. Right. Basically, what happened here? So aluminum transfer an electron, 3 electron to oxygen gas. Try one more time. So who lose electron, who gains electron? Okay. So look at the oxidation number of iron. What's the oxidation number of iron? Well, an atom in its elemental state has an oxidation number of 0. Stay 0 right there. All right. Now, hydrochloric acid, so chlorine group 7 -1, that make hydrogen +1. So they have to balance out, right? On the right side, so again, chlorine group 7 -1, 3 of them. So the total negative charge is -3 total. So iron have to match that by becoming +3. Right? The whole compound has to be neutral. And hydrogen gas, again, an atom in its elemental state has an oxidation number of 0. So 0 right there. All right, so we can see now, so iron from 0 to +3, this is so increase in oxidation number, so oxidation reaction. And so who does reduction reaction? +1 go to 0, hydrogen. All right, +1 go to 0. So iron gives electron to a hydrogen atom. Okay. Types of redox reaction. So a combustion reaction is a type of redox reaction. So if you look right here, we have magnesium burned in the air, right, with oxygen gas. So magnesium from 0 to +2, oxygen 0 to -2. Yeah. Down here, so this is methane gas. So carbon is -4 in methane. In carbon dioxide is +4. Oxygen in regular oxygen 0. In water -2. Okay, so this is an experiment. That's my hand holding a tongue, and the tongue I was holding a magnesium stripe. I burned it with Bunsen burner, and it glows. Okay, produce a bright light. That's the reason why people use group 2 and alkali earth metal in a firework, right? So this is a property of group 2, especially magnesium. When you burn it, it shows a bright light, produce bright light. Okay, and one of the lab you can get to see all this combustion reaction. It's pretty cool. Each ion show different color. We'll talk about this later. Another type of redox reaction. So we have hydrogen and displacement reaction. Okay, so and I'm sure you have heard that a sodium react violently with water. Same thing right here. So sodium +0 go to +1. Hydrogen +1 in water go to 0. So there's also an oxidation reaction. Calcium can do similar thing. Right. However, zinc and magnesium are not reactive enough. Though they can react with water unless you switch from water to hydrochloric acid. They can actually react with it. So produce hydrogen gas. Okay, so in the lab you will quantitatively rank the reactivity of this metal. All right, so you react with this, and you say, is a reaction occur? You react this guy with this, and see if reaction occur, and then you rank this reactivity, who can react the most. Okay, all right. So the application of an oxidation redox reaction is battery. We can't live our life without battery nowadays, with especially our phone, right? When our phone is almost die, well, you kind of get nervous. You need, give me a charger. So a battery anywhere, the car, your laptop, your phone, and automobile, right? Redox reaction have much more application than that. Give you some examples. So electroplating, some type of car, can get rusty. So they coat a thin layer of palladium and prevent it from being rusted. Okay. Fuel cell used in different type of automobile, but NASA also use the fuel cell in satellite. Okay. All right, the last type of redox reaction is called combustion reaction. All right, so making fire. Well, here we go. So in barbecue in the summertime. Now, to make a fire, there are three components that it needs to be met. Okay, so to make a fire, there are three components that need to be met. So we need a fuel, an oxygen gas, and a heat. You need to have all three of these come together. If without one of these components, you can't make fire. For example, all right, to make a fire, this is from methane gas. So there's a fuel, oxygen, and heat. Right? This is propane gas, right? C3H8 or same thing. So fuel, oxygen, and the heat. And always a complete, not incomplete, the complete combustion reaction always make carbon dioxide and water as a product. Okay, all right. So, if you want to make a fire, what do you need? A fuel, oxygen, and a heat, and always the product: carbon dioxide and water. All right. Let's try right here. So, write a complete balanced combustion Write a complete balanced combustion of octane in the presence of oxygen gas and heat. All right. All right. Again, to make a fire, so octane looks like that. That's like a fuel in the car. All right. If you want to make a fire, so that's a fuel. You need an oxygen, you need a heat. Okay, what's the product? Well, carbon dioxide and water. The rest of it's going to be balance this equation. You have to be able to balance it. All right, so we have C8 on the left side, so put 8 right here in front of carbon dioxide, 18 hydrogen, so put 9 in front of water. All right, that makes 16 oxygen plus 9 oxygen, that's 25. So, well, I'm going to put 25 and a half. But we don't really like it, the coefficient in the balance equation as a fraction. We want it as a whole number. So times 2 the whole thing. Here we go. All right. Oh, that's it. What you need to know before you go to the lab. So make sure you know a little bit of moment of safety. All right. Flash point. Pause the video. Read the definition of the flash point real quick. The flash point is the lowest temperature at which vapors of the material will ignite on its own. Right? The lower the flash point, the more dangerous the material. Give you some examples. So let's say a hot day. If a liquid, any type of liquid, so fuel, whatever, has a flash point at 100 degrees Fahrenheit. Well, that's really, really dangerous because, like in a hot day, in a hot summer day, well, the temperature could go up to 100 degrees Fahrenheit, and somehow that liquid just catch on fire. That's really dangerous, right? So they say that the fuel which a flash point less than 37.8 degrees Celsius or 100 degrees Fahrenheit are called flammable. This guy is really dangerous. All right, so watch out for any liquid that have a low flash point. Now, here's the trick right here. So if I have a glass of water, leave it at, let's say, a table for 2 or 3 days, what's going to happen with that water? Well, you can guess that it just goes away, right? Vaporize, and water just gone, right? Well, the water takes some time for water, but the liquid that has really low flash point, For example, octane gas, when you go to gas station, you pick up a nozzle. You probably have seen like octane or the fuel dripping at the tip of the nozzle, right? Watch out on those, because those are flammable liquid, right? As you pick up the nozzle, the octane at the tip of the nozzle already start vaporizing, right? And in this case, if you have a light source nearby, the whole thing will catch on fire. That's the reason why when you go to a gas station, don't bring the lighter, turn off the car, no energy source around nearby. I got a video for you. Let's take a look real quick. Here we go. Not sure if you can hear it, but at least just look at it. So we have a lady parking her car and was it pumping the gas? That's not good. Don't do that. No. Oh, don't get it close. No. What are you doing? Oh. Don't pull it out. Did you pull it out? Oh my gosh. Oh no. Oh, this guy just drive away. What the hell? Go help. Call 911. Well, that's what really happened. Yeah, not good. Okay. Now it says in case in the lab there's a case of fire. What do you have to do? Well, think as a chemist. If you want to make a fire, what do you have to do? You need a fuel, oxygen gas, and a heat. Well, if you remove one of these components, that's it. You win. You put out the fire, right? Give you some example here. So if you pour water into a fire, which component will remove from this fire? The heat, right? Adding water to remove heat out of it, right? What's it called? The fire extinguisher usually has some type of wet agent, right? Or some other chemical that remove some of this. Sometimes it's just a gas that propel oxygen surround the fire, right? What about sand? If you put cover the fire with sand, which component will remove? The oxygen. Good job. The oxygen gas, right? The fire blanket we have in the lab as well. So you pull and you wrap around yourself, and that's how it works. Same thing, right? And that's it. Some of you might enjoy this. Okay. All right. Before Tyler comes in, so he's in here right now. So we talk about him a little bit. So let's pause this right here. So my blood type is B negative. Stop being negative. No. Just want to say, so the outside is cool. I mean, in this crazy world, there are too much negativity outside. So always stay positive, right? So and to do that, you should do this. Surround yourself with weed and tackles, not negativity. I'm just kidding. Just a tackle, not weed. No, not weed. No. Okay. All right. Let's check if Tyler is around.